Hi, in this video we are going over the second part of the solution to the practice final. The very first question is dealing with the type question about the simple interest rate. We learned before that the interest earned is equal to the principal amount of money multiplied by the rate in decimal and multiplied by the time in years. Now let's take a look at the very first example. This question is saying that John invested $12,000 in two different bank accounts. One of the accounts pays 6% annual interest, and the other account pays 5% annual interest. If the combined interest earned in both accounts after a year was $700, how much money was invested in each account? So what we are trying to find in this problem is that what is the amount that John invested at 6% and what is the amount of money that he invests for 5% accounts. They ask you for two different things, so you let that to be x and y, and these are the two variables that you are trying to solve at the end of the problem. So I let x to be the amount of money that John invested at 6% and y to be the amount of money that John invested as 5% account. Now, because we have two variables, we need to find a system of two equations to solve for this problem. Now, how do we find the two equations that we need to use to solve for x and y? You have to go back to the problem, to the statement here. We know that John, he has $12,000 total. That means $12,000 is the total money invested in the two accounts here. That tells you that when you add x and y together, they must equal to 12,000. That is the very first equation from the system that you have in order to solve for x and y. Now, we need another equation to solve for x and y. We have to go back to the problem, and we know that another detail that they give you here was that at the end of the year, he got $700 for the interest, for the combined interest he earned in a year. We know that the interest is equal to the principal amount of money multiplied by the rate and the time t. And we have two different accounts here. The first one is the 6% and the second one is the 5% of money. Now, for each of them, I can find the interest for the x dollars by multiply by the principal amount of money x dollar multiplied by the rate, and the rate here is 6%, and that is equal to 0.06. Now the interest earned on the y dollar is y times 5%, the principal amount of money times the rate, and also times the year in both equations here. But because we are talking about just a year, which is one year, so the time 1 is just nothing here. So we just end up with the principal times the rate, time 1 is just the principal and the rate. That's why we only have x and 6% here, or 0.06x and 0.05y. Now we know that when we add the two interest earned here, we should end up with 700 at the end of the year. So that's why we got the second equation right here. However, to simplify that equation, we can multiply both sides by 100 in order to take away all the decimal places on the left side of the equation. So now you should end up with 6x plus 5y equal to 70,000. And this is the second equation that you are trying to solve to get for x and y. Now, after you end up with the system of equation x, y, we can solve the system of equation by using the substitution, elimination methods. And in this case, I can see that elimination methods may be a good choice. So let's try that now. I go ahead and multiply the first equation by -5. The reason I do that because I want the minus 5 when I multiply to the first equation, that make the y to be minus 5y. And when I get that, I can add the two equations together. So the minus 5y and 5y, they cancel out. 6x add to minus 5x give me 1x. 70,000 add to minus 60,000 give me 10,000. So x is equal to 10,000. But remember, x is the amount of money that John invested in the 6% account. Therefore, John invested 10,000 in the account that pays 6% interest. Remember that we have two different accounts. Once you get 6 for x for 10,000, you can find the amount of the other account by subtracting that from 12,000, because the total was 12,000 in the beginning. He has 12,000 in the two bank accounts. Once you figure out one of them has 10,000, the other one should be 2,000, because 10,000 and 2,000 give you 12,000 total. So the y should be 2,000, or the 5% interest bank account should have $2,000 in there. And that is how you are solving for this word problem using the system of equation. Make sure that you are using two variables, then you expect to have two different equations that altogether give you a system of equation to solve for x and y. Now let's move on to solve this second question for the practice final. We are given a function f of x, and the first part A is asking to factor this function completely. Now if you look at this function, we can see that they have the x4, x to the fourth power, x to the third power, x to the second power. So it looks like that x to the second power is the common term, so that you can pull that to the outside. I can pull the x to the second power to the outside, and if I do that, then the first term I should have 2x to the square, because square and square give back me 4. Now minus 5 stay the same. When I pull out x to the square, x to the second power, I have x left, one more x, because x squared and 1x give me x to the third power. And the same thing to the last term. When I pull out x squared, I only have minus 3 left for the last term. Now, we can still further factor out the inside expression here. So how do I factor 2x squared minus 5x minus 3? Remember, this is the AC method, because we have the coefficient in front of the square term is not to be 1. So we can use something called the AC method. So in this case, this is the quadratic expression that we can have a to be 2, b to be minus 5, c to be minus 3. And now the AC method is telling me that when I have AC multiplied together, I have 2 times minus 3, that give me minus 6, and I have b to be minus 5. I need to figure out the two numbers. When I multiply together, I get minus 6. When I add them together, I get minus 5. And those two numbers can be minus 1, minus 6, and plus 1. Because minus 6 times 1 give me minus 6. Minus 6 plus 1 give me minus 5. So now I can rewrite the middle term here. Let's just keep the x squared term to the outside. Now I can rewrite the middle term minus 5x into the sum of 1x and minus 6x. So the first term 2x squared, I keep that the same thing. The middle term minus 5x, I rewrite that into minus 6x plus 1x. Because minus 6x plus 1x give me minus 5x, so I did not change anything. And then keep minus 3. And now I can factor this by grouping. I can group the first two terms and the last two terms together. Between the first two terms, I see, okay, make sure you keep the x squared again. Between the first two terms, I see that they have a common factor of 2 and also x. So I can pull out 2x from the first two terms. When I take away 2x here, I only have 1x left for the first term, and here I only have minus 3, because minus 3 times 2x give me minus 6x. And then between the last two terms, I don't have anything that I can factor, so I just rewrite x minus 3 here. However, now you can see x minus 3 here and x minus 3 here, they are the common factor. So I can pull that to the front again. So when I take this one to the outside, I have 2x left. When I take this one to the outside, I only have 1 left. That's why now you have, this is the multiplication of x minus 3, 2x plus 1, and x squared. Or I can simplify that as x squared times x minus 3 and 2x plus 1, and this is the factor form for this function f of x. Now for the second part B, they ask us to find a 0. That means you want to find the value of x that make the function f of x to be 0. This is easy because we already have the function in the factor form. So I can set this factor x squared, x minus 3, 2x plus 1 to be 0. And this is already in the factor form, so I can set each of the factor to be 0 and then solve for x. The first one, x squared equals 0, that tells me x to be 0. X minus 3 to be 0, adding 3 to both sides, I get x to be 3. Now for this one, I can move 1 to the right hand side first. So I have 2x equal minus 1, and dividing both sides by 2, I have x to be minus 1 over 2. So 0, 3, and minus 1/2 are the solution to add a 0 to this function f of x. Now the next question is asking you to find the intervals for solving the inequality 2x to the 4th power minus 5x to the 3rd power minus 3x squared less than 0. Well, solving any inequality is similar to solving the equation. The first thing is we need to find a boundary. So now I can do that. I can first find a boundary where this function is equal to 0, and then we can do some testing to see which interval that's really give me the value that is less than 0. So anytime that we are solving an inequality, we need to find the boundary. In this case, the function of f of x less than 0. So now we want to find a boundary where the function is equal to 0. And we already found that in part B. So now all you have to do is to draw the number line system. I know that my x is 0. This is one boundary. Minus 1/2 maybe is here. Minus 1/2. And then 3 to be here. So we have one boundary here to the left of minus 1/2. One region between minus 1/2 and 0. One region between 0 and 3. And all the way to the right of 3. Okay, we can do some testing now. So you need to find the interval where this function is less than 0. So make sure it is less than 0. So I can do some testing. Now let's do some testing for the number line here. Let me rewrite a function right here so we can do some testing. F of x equal 2x4 minus 5x to the third power minus 3x squared. Okay, so we have to do some testing for the region on the left side of minus 1/2. We can pick some value on the left side of minus 1/2. Let's pick minus 1. So f of minus 1. When I plug in minus 1 to the function here, to any of the x, I see x, I plug in minus 1 in, I get the value of that to be 4 of the whole expression here. And 4 is bigger than 0. But we want something that is less than 0 for part C. You want something that is less than 0. But here, it is bigger than 0. So this region is not the answer. So we cross it out. Now between minus 1/2 and 0, I can pick a value to test. Let's say f of minus 0.2. Because minus 0.2 is between 0 and minus 1/2, which is minus 0.5. So I can plug in minus 0.2 to this function here. And then I got the value of minus 0.1538. And this is less than 0. So I know that, yes, this is the region for my solution. And then between 0 and 3, I may be picking one value between that. I pick 1. So do some testing. You also get the value to be minus 6, also less than 0. So yes, for this region. But the last one, after 3, I pick one value, maybe 4, and I get something bigger than 0. So this is no. So your answer for this one is find the interval for solving the inequality. Oh, we already did part D as well, because part C is only asking for find the intervals for solving the inequality. Finding interval, that means you are finding this interval here, which is minus infinity up to minus 1/2, because this is not including the equal sign, so we only use the parentheses, open parentheses. And then we have another interval from minus 1/2 go to 0, and then 0 go to 3, and then 3 go to all the way to infinity. This is the 4 intervals that we are looking to test for the function from part C right here. But then for part D, they ask you to find a solution. That means I did some testing here, and I end up with only these two areas, or only this one and this one are the two intervals that are really the true solution to this problem. So we did all together part C and part D together, and that is the end of this problem. Now let's try the last question from the practice final, and this question was taken from example 10 from page 334 of section 5.1. Now let's just work out a problem again. We are given a function f of x equal 2x to the third power minus 11x squared plus 12x plus 9, and this is also was given in the factor form. The first question was asking you to find the x-intercept for the function. Now to find the x-intercept, anytime that you are trying to find the x-intercept, you are letting y or f of x to be 0, and you are solving for x. Now, when I let this function f of x to be 0, I means that this factor form is also equal to 0. So we let that to be 0, which is x minus 3 squared equal to 0. And this is equal to 0, tells me that the two-factor term they have to be equal to 0. So either 2x plus 1 equal to 0 or x minus 3 equal to 0, square equal to 0. And if I solve these two equations here, the first one I move minus 1 to both sides. I got minus 1 on the right side, and I get x dividing both sides by 2. I got x to be minus 1/2 for x-intercept. Now this is the square. Then I can, because the right side is 0, so I just get x minus 3 to be 0 or x equal 3. Because this has the square, the power of 2, so that means x equal 3 is the 0 or the x-intercept with the multiplicity of 2. Right. Now this is for x-intercept. You are trying to find, for B, you are trying to find the y-intercept. Now for y-intercept, again, we let the x to be 0 and then solve for y or f of x. So for y-intercept, I let x to be 0. When x is 0, I can solve for f of 0. Anywhere I see x now becomes 0. So this is 0, this is 0, this is 0. I have only 9 left. Because 0 times 2 is 0, 0 times 11 is also 0, times 12 also 0. So I only have 9 left. So the y-intercept in this case is 9. Now the last step, the last question here is to graph the function. Now in order to graph the function, we can apply some of the way that we learned in the class before. So let's graph this function. The first thing is you can graph the x-intercept and y-intercept first, so that you can get a good idea of how the function, how the graph should look like. So I go ahead and I graph the function. I know that my y-intercept is 9, so maybe let's this is to be 9. Just put a 9 here, right? 9 for y-intercept. Remember, the scale may not be correct, but this is a general idea, the general graph of the function. So y equal 9 for the y-intercept. For x-intercept, I know one of them is 3, so maybe around here is 3 for x-intercept, and then minus 1/2, so closer to the 0, so this is minus 1/2. Okay, so the next thing is, this is a polynomial to the 3rd degree. How do I know the end behavior? How do I know if the graph on the right hand side here is going up or is going down, or the one from the left here is going up or going down? There's no way we can do that unless we do some testing for a few points, but that is more work. But we know that from section 5.1, go back to section 5.1, we can take the leading terms and we can check for the end behavior. So the leading term is the one with the highest power, and if the power is even and the coefficient is positive, then the two sides, the two end behaviors, should be going up. Now let's go back to our example. We have the leading term here in this case to be 2x to the 3rd power. So the coefficient is positive. A n is positive. And this is 3. So this is the odd value. So go back to section 5.1, the notes here. We know this is positive, the odd power n. Therefore, the 2n behavior should look like this. If you are moving all the way to the right, it should be going up. If you are going all the way to the left, it should be going down. So I know that I should get something going up here, and then I should get something going down this way. Right. So after I figure out the 2n behavior, the next step is, in order to graph this polynomial here, I should also consider something that we learned from section 5.1. That is the multiplicity of 0. Now, if a 0 has an even multiplicity, then the function should touch the x-axis as that's 0. If the 0 has the odd number of the multiplicity, then the function should cross the x-axis at that 0. Now go back here. I have the 0 of this function, meaning that f of x is 0, and f of x is 0 is here. We are solving for f of x is 0, which give us these two values, and this one is a linear, so x equal minus 1/2. This is a multiplicity of 1, but this one has a square power, so x equal 3. This has a multiplicity of 2. This is 1, this is 2. So I know that if you have the even multiplicity, the graph will touch the x-axis. If you have the odd multiplicity, the graph will cross the x-axis. Now we have the even, the 2 is the even, so 2 is right here. So the graph will touch the function at this point. It will only touching the 3, but not crossing. So so from here, you know that in order for you to go from this higher point to this lower point, you are decreasing to here. But then you know that if you are going to the right, you have to end up somewhere around here, and you cannot cross to the x-axis because this is the multiplicity of 2. Therefore, you just touch that and then moving up and then just connecting to the right side to this point here. Now, the other one is minus 1/2 for the 0. This one has the multiplicity of 1, and we know that 1 is the odd multiplicity, and therefore the function will cross the x-axis. So in order for you to go from here to here, you have to decrease to here, and in order for you to go from here to this end behavior, that's the only way that you have to do, is you have to go to that. So go to that. That means you have to cross to the x-axis and go to this side. So this is a rough draft of the function. But if I draw that again, I know that this is 9, this is 3, and this is minus 1/2. And if I draw that correctly and clearly, I can see that this function is decreasing, this k, and then it's also decreasing here, but then it's increasing. So I just redraw to make it look nicer. And this should be the function, the graph of our polynomial here. The last part here, they ask you, does the graph have the absolute max and absolute mean, both or neither? So how do we find if the function have the absolute max, the absolute mean, or neither? Remember, in this case, any time that you are solving for the absolute max or the absolute mean, we need to have a closed interval, the closed interval. But here we are considering from all the way from negative infinity to up to positive infinity. So we don't have the closed interval. Therefore, the function here keep increasing forever. It's increasing to the right side. It's decreasing all the way to the left side to negative infinity forever. Therefore, we don't have a max, the absolute max, or the absolute mean in this case. So we should choose the neither in this case. However, we do have a local max and a local mean, which is this point and this point, but not the absolute one, because the absolute max is the maximum value of the whole function on all the x-axis, and the absolute mean is the minimum value for the whole things. But because we have all the way to positive infinity to the right, and the function keep increasing forever, we don't have the max value. The same thing to the left side here is keep decreasing forever, so we don't have the mean value. So we don't have any absolute max, any absolute min, but we do have the local max here, the local min in this case. So for D, the answer should be neither or none of them. So that is the end of this part 2 solution, 3 questions, and thanks for watching.